Okay, so now we're going to start talking about, I believe this is chapter 13 in our text on building information systems. So the last lecture was on the best practices around managing and operating an IT service, IT organization that delivers IT services and value. Now we're going to look at exactly what that looks like in one particular area, which is developing information systems. It's actually a really short lecture because most of the time is normally taken up with a particular activity that I'm moving into next week, where we're going to practice some of the foundational pieces of building an information system, or a process approach that we use a lot at OU. So let's just jump straight in. So a couple of things just to set the groundwork. Um, the reason that you're building an information system in most cases is to support some kind of structural change within the organization. Uh, that can be in a number of areas and they cross each other in their value and importance. We have organizational change, so perhaps there's a new thing the business is trying to accomplish, and so you develop an information system to support that new thing. Sometimes it is using, we're going to look at some systems development processes for how you get from idea to actual implementation. And we're going to also look at a few alternate approaches to how you develop an information system. That's the content for tonight. The idea of structural change, though, back to that first topic, is enabled by IT in several ways, or supported by information systems in several ways. And you see those four bullets there we're going to look at in a little more detail. But first of all, the idea of automation. And that's, I mean, simply just the most direct, obvious way is replacing a manual task. I think back to if we would have this discussion if we were having class live, but think back to our barbecue restaurant of the topic. And I believe we actually even talked about this one already, of taking some manual tasks and automating them. So placing an order instead of writing down on a piece of paper the sandwich orders, perhaps the ability to enter that data electronically from a list of things, so you always get it accurate and nobody has to decipher your handwriting. You're simply replacing a manual task with an automated approach and making it more efficient, in theory, making it more efficient. So that kind of structural change can be enabled by something as simple as automation. The next level up, though, is this idea of rationalization of procedures. It's kind of a fancy and full mouthful of terms, but what it simply means is standardizing the way things happen so that they happen consistently and in a way that is effective, more effective perhaps than it had been. So that first bullet there of streamlining SOP. SOP stands for standard operating procedures, and it's just a set of procedures that you do over and over. They're the standard operating procedures. So every time you make this particular barbecue sandwich, you put the bottom bun, and then you put the meat, and then you put the sauce. You don't put the sauce and the meat. And you think, well, what difference does that make? Well, if you've looked at that process, you know it makes a difference, because later on, perhaps we grill the top surface of the bun, and so that keeps it from getting soggy. Whereas if you put the sauce on first, the bottom bun hasn't been toasted and it gets soggy, or there are reasons that you've looked at for why you want to follow that operating procedure. Well, you can do some of that same kind of thing. That's by taking information systems to help standardize. If something is supposed to be done the same way over and over and over again in a particular area, perhaps you can simply just automate that, or you can take it and use information systems to make that more convenient. A couple of really important terms here that you may or may not have heard before, that are really important in this particular area, and that is they're called quality initiatives. In many cases, there's Six Sigma is one of those, total quality management, or TQM. TQM is kind of I don't know, I don't necessarily hear that much anymore. But I do hear one that's actually not on that slide called lean, Lean, as in making something that's fat, leaner. Um, and that's the idea of taking stuff out to make it more efficient. A lean process is a process that's been examined and used in such a way as to make it faster and faster and faster. So I actually had the opportunity to take a lean certification course a couple of years ago, and the ideas are really interesting and innovative. It comes out of the manufacturing world, particularly the car manufacturing world. And if you think an example that is very typical that they use to help understand this part of it is if you're on an assembly line and you're building a vehicle and somebody's observing your process. So a person is standing at this point in the assembly line. They have to walk 3 steps over this bin and get a part and walk back 3 steps and then put that piece onto the vehicle. Well, a lean approach to that process is going to ask, why is the part 3 steps away? Because in total, that requires 6 steps. Well, you might think, okay, that's just going to take 1 or 2 seconds. Well, that's true. It will only take 1 or 2 seconds. But if you lean out that 1 or 2 seconds and make it half a second to grab the part and place it on, over time, over a number of people and over a number of facilities, you can actually increase the quality as well as the time, the total time, turn time is what it's called, how fast you can turn a product out. And all those initiatives, Six Sigma and Lean in particular, are all about increasing the quality of something to make it better. That is information technology and information systems approach can help each of those areas. There's actually a whole sub world of the lean IT and what that looks like. So that's another area that information systems can bring structural change, is through rationalizing procedures. We don't have time to go into too much of that detail. The third area there is business process redesign, and we've talked about business processes. It's basically taking rationalization of procedures and taking it to the next step. We've talked a lot about that one, so I'm not going to spend time on it. And the last one is paradigm shifts. Don't really hear the word paradigm shifts much anymore, but it was a big term back in the 80s at least, where you were talking about using information systems, or in that case, it wasn't necessarily information systems, but in our case it is, and using whatever innovation you were bringing to the table to completely change what this company did. So Netflix went from being a company that was about distributing DVDs to being a company that streams content. That would be a paradigm shift, and there are probably even bigger ones than that. But we'll look at a couple of things around those things. If you put those 4 approaches on a map, they kind of provide an interesting risk and reward graph to look at. If you think about the reward is the horizontal axis, and it's simply a relative measure of how much value you could potentially get out of that. Whereas the risk register on the vertical axis there is about, well, how risky is it to try that? And it's really a straightforward relationship. Automation is really easy to do, meaning it has a very low risk, but its return is relatively small compared to something else. Rationalization is a little harder to do, more risky. You risk disrupting the organization more, but it can bring you more value and return on the other side, the flip side. Then you keep moving up the stack. Redesign is much harder to do, more risky to the organization, higher risk of failure, but it can drastically change things in the organization. And then paradigm shifts are hugely risky. They can fail spectacularly, but when they work, they can be of extreme value to the organization. So it's just a little interesting map of how that works. All right, so when it comes time to actually developing an application or an information system, and I'm going to actually use those words interchangeably in this section. So often we talk about building an application, or building a piece of software, or building a capability. I'm going to just use all that stuff together. And instead of purchasing something, we're talking about developing the capability inside of the organization. A process that is often used and is very typical is this one that I'm going to expand on in a future slide, of the idea of, first of all, you analyze the problem, then you design the solution, you program the solution. That's literally when the developers, that's typically they're software developers or application developers, they take the design and they go and do all the coding in whatever language they may be writing the software application in. Then they program it, then you test it, and then this final step is called conversion. It's typically you're taking data from an old way of doing it and putting it into a new way of doing it. It's called a step called conversion. You want to convert the data from the old to the new. It's typically a really important step. And then finally, we're in production and maintenance mode. You can actually see some of the concepts of ITIL layered across some of this. You see the design, that's a one-to-one correlation. But transition would really fall across programming and testing and conversion, and then operations would be the production and maintenance part of this development process. So just a very high-level overview of how you get something from an idea to a solution in the application development world. I'm actually going to skip this slide because we're going to come back to it in week 6 and when we do our activity. But the point that's just to consider at the very, very high level is not everything that goes into building a solution is technical. And you shouldn't be surprised by that, because there are there are organizational and there are management and there are technical considerations to any application or software or information system that you're developing. Okay, a couple of models that it's important, I think you know some terminology around, and that is, the first one is something called SDLC. That actually stands for Software Development Lifecycle. Software Development Lifecycle. And it is often also called a waterfall method. And that's because if you draw these out, if you're familiar with a term called Gantt charts, and that's a project management term that essentially lists a topic that has to be accomplished, lists all the topics or all the tasks that have to be accomplished on one column, and then you draw start and stop lines across in a horizontal manner. And perhaps you might have one that starts here and the next one starts shifted over a little bit because it's dependent on this one. It actually creates a graphic or an image that looks like a waterfall, and that's why it's called a waterfall method. But the whole idea behind it is you get the entire big giant list of things and tasks that have to be accomplished, and then you map them out about how they sequence or work together. That is a development methodology that is the primary development methodology, but it's also one that's falling out of favor. And in large part, it's because the speed of business is moving much, much faster than it used to. Things have to happen fast. And the biggest drawback to SDLC is that it starts with this idea that you have a completed list of all the tasks that need to be accomplished. Well, what if you don't have a list of all the tasks? What if you have the first 10 and then the rest of them you kind of discover as you're going? Well, that really throws off a software development lifecycle approach, a waterfall approach. And so typically what we have seen is the idea of some other areas that have developed: prototyping and Agile. Agile is one we're going to spend just a minute talking about, but prototyping is the idea of developing a prototype and then testing it, and then going back and forth and back and forth. It's very similar to Agile, so I want to spend the time talking about Agile. Agile methodologies are really interesting. They have a lot of great terminology, things like scrums and stand-up meetings, and I don't know, there's some other terms around Agile that I find that are just interesting terms. But the idea behind Agile is that you work in much, much smaller groupings. So you don't have to know all the tasks. You just have to know the first 3 tasks, or the first small number of tasks. And you go and work on those. And you bring them back to the customer then and say, here's what you asked for, here's what we developed the first little bit. Is this what you wanted? And they say yes or no. And if they say yes, then great, you've got the first step, and then they give you the next couple of steps. It's a much more agile, faster methodology for getting something in place. It has these ideas of stand-up meetings. So every morning when you're in an agile project, you meet and you meet for just a few minutes. And so because it's such a short meeting, I've seen places that actually take the chairs out of the room. So you can't sit down, and therefore it gets this idea called a stand-up meeting. But it's a very short meeting. It basically asks 3 questions. What did we say we were going to do? Here's what did we actually do, and what are the impediments to us doing moving forward on the next steps? And you just meet on those things very quickly. The whole idea behind the Agile methodology is to develop content or to develop capabilities, the application capabilities, faster and more repetitively in a way to get it in front of the customers more frequently so they can tell you, yes, this is the direction we wanted to go, or no, it's not the direction we wanted to go. You can give them parts of their solution along the way rather than having to wait for the full delivered application at the end. Much faster and typically more well received. A couple other development models is important to, well, they're not really development models. They're related to the development of something, and that is the idea of outsourcing software as a service, and we've already spoken about open source. Those are other ways for you to get the capabilities you're trying to deliver besides going and developing them yourself, but we've already covered those, so we're not going to spend much time on them here. The last thing I want to talk about here is this idea of sourcing. I mentioned it earlier in one of the other slides, I believe, but where do you get your software? If you're not going to, well, it's not the question if you're not going to, it's a question of how do you decide whether to build or to buy something. So how do you source this piece of software? Or how do you source your application or your business process? How do you source this information system? Do you build it or do you buy it? And there are definite pros and cons to both sides of the house. If you build it, you have a great deal of control over what you build. But at the end of the day, the negative is you're responsible for that. If it's broken, you're the one that has to fix it. And if the skills are no longer in your organization, there's nobody else you can give it to because you're the one that built it. If you buy it, you're kind of expecting somebody else to do the quality control of that application. But in many cases, they're also going to design it to meet the needs of lots of different customers, not just you. And perhaps it doesn't actually do what you want it to do, and you're left having to try and make it configure it in a special way or edit it in some special way to meet your particular business needs. Lots of questions go into whether to build or to buy, but the important point I want to make here is that that is not a technical decision alone. It certainly involves the technical side of it, but is by far more of a management and organizational decision than it is a technical one. So that's a brief overview of the application or system development world and what it looks like, some things that organizations go through to try and identify the issues around obtaining new information systems, what they want them to do and how they want them to work. And we'll apply some projects to that in our next meeting.